All right, let's talk about circles. Also, I should, okay, there's the chat. Yes. I think I emailed you back, Eve, so you should take a look at that. And we're just gonna have the chat there. So don't chat me anything too private, which is too bad because so I'll just point out, in the past when everything was on Zoom, students could totally send me private messages, and it was obvious. As Eve did. Sorry to show everybody to your stuff, Eve, but that's what we've got. And I'm going to try and figure out a way to do this better, but it hasn't come to me yet. So for now, we are in a world where the messages I get on Zoom are not private. So just be aware of that if you're sending me things. Okay. Hope you guys had a nice weekend. Welcome back to another week of first full week of UC Davis, or first full week of this school. UC Davis. Circles. The equation of a circle is usually written like this: x minus h squared plus y minus k squared equals some number r squared. This is what's considered the standard form. The center of the circle written this way is h comma k. The radius of the circle is r. And there's not a whole lot else to say about this particular equation. There is another version, which we're going to talk about in a little bit. But this is kind of, if someone is writing the equation of the circle, this is the way you want to write it, right? This is the best way for sure, no matter what. So let's look at this next circle here. We want to graph it. And the way we're going to graph the circle is first by identifying the important features of it. I should also mention, just because it is worth mentioning, the center of the circle is actually not part of the circle. Right? The circle is all the points on the circle. Welcome. And also grab the first 5. Oh, looks like someone didn't get the maybe last couple pages there. You want? Yeah. Grab the first 5 pages. Yeah, the center is not part, but it's an important feature of the circle. Just like, well, that's not really a good example, so I won't say it. What is the center of the circle? So we're looking for the x and y coordinate that make, the way I really think of it is, I mean, I know I've got x minus 2 and y minus 3, so it's not too terrible to see that the center is the point 2, 3. But the what I'm really thinking of when I'm trying to find the center of a circle is the x and y values that make the entire left-hand side equal to 0. Right? X is 2, 2 minus 2 is 0, and if y is 3, 3 minus 3 is 0. So it's always the values that don't solve the equation, right? 0 doesn't equal 25, but they are the values that make the left side equal to 0. The radius is the square root of 25, which is equal to 5. And now we're going to graph it. The way I like to graph this is by plotting the center. Then I'm going to go 5 in each of the 4 directions. I'm going to go 5 to the right, 5 to the left, 5 up, 5 down. So 1, 2, 3, 4, 5. 5 up, 5 left, 1, 2, 3, 4, 5. 5 down, 1, 2, 3, 4. I don't think you need to label these points, but you certainly could. Right? If this is the point 2, 3, if I add 5 and to the right, I'm adding 5 to the x coordinate and getting the point 7, 3. If I add 5 to the y coordinate, I'm getting the point 2, 8. I subtract 5 from the x coordinate, I'm getting -3, 2. And if I subtract 5 from the y coordinate, I'm getting 2, And then we try to draw the best circle we can. Sometimes they look good, sometimes they look terrible. That's all right. Pretty decent circle. So I don't think you need to label these 4 points here, but if you feel like you've maybe drawn the worst circle ever and you want me to know, like, hey, I still know what we're supposed to be doing, I just didn't do a good job of drawing the circle, that's something you might consider doing. And there's the center at 2, 3. Then we also have a couple formulas down here. We have a formula for the distance between 2 points. It is the square root of the sum of the squares of the differences between the point of the coordinates. So it's the square root of x1 minus x2 squared plus y1 minus y2 squared. And the midpoint of 2 points is, as I like to think, the midpoint is, I always want to say to myself, it's just the average of 2 points. So if you have a point, if you have, I should say, points x1, y1, and x2, y2, the midpoint, the x coordinate is the average of the x coordinates. The y coordinate is the average of the y coordinates. It's a really kind of convenient way to think about the midpoint of 2 things. Just the middle. Right. So let's put all those things to good use here. We're going to find the equation of a circle that passes through -6, 1, and 2, 7, which are diameter endpoints. We don't have to draw a picture here, but I'm going to draw a little picture just to make it kind of helpful. So let's say here's our circle. What we're saying is -6, 1, which might be, I don't know, let's say it's over here, and 2, 7, which is over here. Those are endpoints of a diameter. And the diameter specifically goes through the center of the circle. How could we find the center? What is it? That's the term. I'm like, how do I say this question? If we know the endpoints of the diameter, the center of the circle is exactly the midpoint or the average. So the center is just going to be the midpoint of those 2 points. So the x coordinate is going to be the average of 2 and -6. I'm just going to do 2 plus -6 divided by 2. And the y coordinate is the average of the y coordinates. It's going to be 7 plus 1 divided by 2. And that's going to end up being 2 plus -6 is -4 divided by 2 is -2. And the y coordinate is 8 divided by 2, which is 4. So there's my center. And whenever I'm asked to find the equation of a circle, I'm always going to find the center first. Now I want to find the radius. And there's 2 equally valid ways of doing it. You can either find the distance between the center and either one of the endpoints, and that would be the radius. Or if you didn't already have the center, you can find the distance between the diameter endpoints and then cut it in half. Either way would be fine. Since we found the center, I feel like that's probably the more normal way of doing it. So if I'm going to find the radius, it's going to be the distance between, and it really, really doesn't matter which of the 2 points I pick. So I'm going to pick, I should say, it doesn't matter which of the 2 endpoints I pick. I'm going to use the center, -2, 4, and the other point, -6, 1. So my distance, which I'm going to call r because it is the radius, is the square root of the difference in the x's. So -2 minus -6 squared plus the difference in the y's, 4 minus 1 squared. I will mention for the distance formula, it doesn't really matter if you get the order reversed. Like I could have just as easily done 1 minus 4 here and still end up with the same answer. But it's good to be consistent, meaning if you're doing this x coordinate minus that x coordinate, it's a good idea to do this y coordinate minus that y coordinate. Just keep things in the same order. Because although it doesn't matter for this formula, there are definitely other formulas where the order really does matter. So it's good to keep things all nice and neat. Let's see what we get here. -2 plus 6 is 4 squared. 4 minus 1 is 3 squared. And we get the square root of 16 plus 9, which is the square root of 25, which is 5. I do want to take a brief moment here just to point out that the square root of 4 squared plus 3 squared is not 4 plus 3. Right? It's not 7, it's 5. Right? So we can't distribute a square root like that. We have to deal with the insides before we square root it. And now we're going to write the equation. So I know the center is -2 positive 4. I know my radius is 5. I know the standard equation. It's going to be x minus the x coordinate, which is -2 squared, plus y minus the y coordinate, which is 4. And then it's equal to the radius squared. And if I were writing this in what would be considered maybe a more simplified form, I would probably write it as x plus 2 quantity squared plus y minus 4 quantity squared equal to 25. Thank you for the zooming in suggestion. At first I was kind of like, this is not going to go well. I think it's going pretty well. I think it's a good idea. Good job. I try to be open to suggestions. I feel like sometimes I'm a little too rigid in my mind. So that said, like, feel free to suggest things. I will try to be open to them. I'm not against changing or doing things differently. We just get set in our way sometimes as we get to be older people. So anyway, now we come to another question about finding the center radius of the circle, but that doesn't look like the standard form of a circle. Right? We don't have x minus something quantity squared plus y minus something quantity squared equal to a radius. If you thought this was the form of a circle equation, you'd be like, that circle has a radius of 0. That seems probably wrong. So we need to write this in the standard form. And the way we're going to do that is by completing the square, which is really the reason we kind of talked about completing the square last class, is so we could see it before we use it here. We're going to complete the square for both the x's and the y's. So here's how I would recommend writing this. Yeah, so I would first move any constants to the right-hand side, which we often abbreviate as RHS. So I'm going to rewrite my equation as, x squared plus y squared plus 2x times 3y equal to negative 11 fourths. And then we want to, oh, in fact, so this is not something we have to do for this one, but it is something we're going to have to do for the next one. I'm going to write it in red. If x squared and y squared have coefficients that aren't 1, divide everything by that coefficient. So I actually didn't have to say it. If it is 1, you can still divide everything by 1. It's just not going to change anything. So divide the entire equation by the coefficient of x squared and y squared. You might ask, well, what if they're different, James? And I would tell you that you don't have a circle. So if x squared and y squared have different coefficients, you have an ellipse probably, or something, some other conic section. You don't have a circle. So since we're only dealing with circles, x squared and y squared will always have the same coefficient, which is great. Step 3, group the x's and y's together. Yes, thank you. You know it's going to happen eventually. So I want to rewrite this equation as x squared plus 2x. And honestly, you want to leave yourself some space after the 2x. And leave space. So x squared plus 2x, I'm even writing a plus blank. And a y squared, what have I got? Minus 3y plus blank. It's going to equal negative 11 fourths. So the blanks are where I'm going to fill in the completed square. Let me just do this. Sorry. It is going to be a little challenging. Sorry. I should just do that. Okay. So step 4, actually do the completing the square. So to complete the square for the x terms or for the y terms, we're always taking the coefficient of the thing that's to the first power, dividing it by 2, squaring it, and adding it up. So I'm going to take 2, I'm going to divide it by 2, and I'm going to square it. And that's going to give me a 1. And I'm going to take negative 3, divide it by 2. Try not to little, you can mostly see that, I think. Negative 3 over 2 squared is going to give me a positive 9 fourths. But if we do something to one side of an equation, we have to do it to the other side. So either your choice is to, like we did kind of for the parabola, you could add one and subtract one, add 9/4 and subtract 9/4, but it makes more sense for circles especially to instead add both those things to the other side as well. So I'm going to add a 1 over here, and I'm going to add a 9/4 over here. You might have noticed I'm kind of missing a plus sign between my 1 and my y squared. I should correct that. That looks much better. All right, the last thing to do is to factor. So the thing is, if you have completed the square, you know how they factor already. So x squared plus 2x plus 1 factors as x plus 1 squared. And you know it's plus 1 because it's always going to be whatever this number is, not squared. 2 over 2 is 1. That's what I'm going to get there. I'm going to get the x plus 1 squared. Which that one, okay, fine, right? You could probably pretty easily be like, oh yeah, x squared plus 2x plus 1. The only numbers that multiply to 1 and add to 2 are 1 and 1. It's a little harder to answer that question for the y squared minus 3y plus 9/4. It is true, the only numbers that multiply to 9/4 and add to -3 are -3/2 and -3/2. But it's easier to say to yourself, oh, it's always going to be whatever that number in there is. I know it's kind of hard to read. It is a -3/2. Whatever is in there, that's the thing that ends up in your factor. So this is totally going to be a y minus 3/2 quantity squared. And on the right-hand side, we get a -11/4 plus a 9/4 is going to give me a -2/4. And then plus 1, well, 1 is 4/4. 2/4 plus 4/4 is 6/4, which reduces to 3/2. Which I feel like I've made a mistake there because, oh no, I did. I lost a sign in my head. So I said 2/4 plus 4/4 is 6/4. But what I actually had was -11/4 plus 9/4 is -2/4. And -2/4 plus 4/4 is +2/4. So I don't have 3/2 here. I have 1/2. Which is a good reason to show your work, right? Because it would have been very easy for me to have missed that. If I didn't have these notes here that I'd done before telling me that it's 1/2, I'd be like, oh, I just would have flown by me, right? So it's really good to actually write things out, which I don't have the space to do, which is why I'm kind of cramming things in here. Yeah, writing could be better, I guess. I don't know. Like it could be smaller, but I don't think it should be smaller. It could be bigger, and then I would have even less on the page. So to answer the question, which I guess I'll write up here, the answer to this question is, yeah, okay. So the center, oh, I always keep forgetting to do this. This makes it a little easier to see more things. Like this. What's the x coordinate have to be for the center? +1 or -1? -1. How about the y coordinate? +3/2. And the radius is going to be the square root of 1/2. Which you could leave as is. Some people like rationalizing this. You could say this is the square root of 1 over the square root of 2. The square root of 1 is 1. And then you can multiply the top and bottom by the square root of 2 to get the square root of 2 on top and 2 on the bottom. That's not super important, but it is something people do. So there's the center and radius of our circle, which is what we were asked for in the beginning. If you're given a circle written in this, what's called, again, this is an example of what's called the general form of an equation. We have kind of just all the powers of x and y written in descending order like this. It's a very general way of writing things. It's not a very informative way of writing things, right? Writing it this way doesn't tell us really anything about the circle. Whereas writing it in this much nicer standard way kind of tells us everything we ever want to know about the circle. Someday that will feel less weird, maybe. Oh yeah, go ahead.
This is clarify, you did say that the b squared minus 2, that number, will that factor always be used in
So the b, you mean the b over 2? Yeah, exactly. So the b divided by 2, excellent question. The b divided by 2, which is the 2 over 2 here and the negative 3 over 2 here, that's exactly what is going right there or right there. And you do keep the sign, right? If it's positive, it's positive. If it's negative, it needs to be negative. All right, let's look at the next one. Yeah, I should do this. Do this. Okay. We want to graph 2x squared plus 2y squared minus 10x minus 2y minus 5 equals 0. Is it a circle? Yes. How do you know it's a circle? Because x squared and y squared have the same, usually positive coefficient. That always means, I should say, so if you have that and you only have lower powers of x, like the first power of x or the first power of y, pretty good chance it's a circle. How do we make it look like a circle, right? Because although, like, we know it's a circle, we need, if we want to graph it, which we're being asked to do, we need to know where the center and radius are. And what we really want to do, well, we want to follow the instructions. I mean, we're following a recipe, right? We're just trying to write it like we just wrote it. So we're going to do the same thing we did before. We're going to bring the 5 over here. 2x squared plus 2y squared. If I were doing this, I don't know, if I were doing this like I'm not doing it here, I suppose I would have maybe grouped the x's and y's together in this first step as well. I just didn't because I wasn't thinking about it. And now I want to divide both sides by 2 because I really don't want that coefficient. In fact, this is a good thing to do if you're ever completing a square and you have an equation. If you can get the thing that's squared to have a coefficient of 1, that's usually always going to be in your interest. So I'm going to divide everything by 2. I'm going to get x squared plus y squared minus 5x minus y equals to 5 over 2. Fractions all the time. Okay. Now we're going to group the x's and y's together, and we're going to be smart. We're going to leave ourselves some space because we know we're going to be completing the square. So I'm going to write this as x squared minus 5x plus blank, and then plus y squared minus y plus blank equal to 5/2. And then I'm going to add those same things over on the other side. I'm giving myself room there. All right, my completed square numbers are going to be fractions as well. I'm going to take a -5 over 2 and square it and put in a 25/4. And I'm going to add that over here as well. And I'm going to take a -1 divided by 2 and square it. I'm going to add on a positive 1/4. Whenever you're completing a square, you're always adding on a positive thing. Always, right? Because you're always squaring something and then adding it on. So it's got to be positive. All right. This is going to factor. It's going to factor as, let me put some parentheses around it. So this is going to become x something squared. What's the thing I'm either adding or subtracting? Right, I'm subtracting 5/2. Or I guess you could also say you're adding -5/2, but right, we're subtracting 5/2. And then for the next term, it's going to be y quantity squared. You could multiply it out, right? If you multiply this out, it's y minus 1/2 times y minus 1/2, and you would get y squared minus 1/2 y minus 1/2 y plus 1/4, which is exactly this. And on the right-hand side, I would reimagine 5/2 as 10/4, and then 10/4 plus 25/4 plus 1/4 is going to be 10 plus 25 plus 1 is 36/4. fourths. So that came out nice. It's actually a nice whole even integer number, which is 9. So my center is going to be x is 5/2, y is 1/2, and my radius is the square root of 9. Oh, thank you. Which is 3, right? That's 9 right there. And now we're going to graph it finally. So I'm going to plot my center, which is at 5/2, 1/2. So 5/2 is 2.5. 1/2 is 1/2. There's my center right there. And then I'm going to go 3 in each of the 4 directions. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And we try our best. Something to think about when you plot these 4 points is they're kind of the extremes of the circle. Right, this point here is the top. The circle doesn't go any higher than that. This point here is the bottom. The circle doesn't go any lower than that. So when you're drawing the circle, kind of think about when you're coming like at this point here, that should be the very bottom, and then it should keep going up as you go to the other side. Okay. And that's, I think, most of all there is really to say about circles. Circles are not too terrible. All right. So let's talk about the other thing we're going to do, which is word problems. I mean, you could use other fancy things to say, oh, but it's word problems. So we're going to talk about, so interpreting mathematics from words is kind of a super big deal. How many of you are planning on taking the 17 series? Okay, a fair amount of you. How many are planning on taking the 16 series? How about the 21 series? Okay, so the majority of you are planning on taking the 17 series. And not that the other classes don't have word problems, because they certainly do. But I would say of the 3 series, the 17 series is probably the most like taking real life situations or made up problems that are most supposed to represent real life situations and taking the words around that, interpreting it into math. It is something that you are going to have to be able to do. And depending on your teacher, some of them really, really emphasize it. Like they have like discussion sheets, which I mean, I think they're good. I've done a lot of them. I think they're well thought out and actually make you learn stuff, which is great. But you have, like, part of it is really getting you to interpret math from words. And so we're going to practice that. And then some of the examples might feel contrived. That's all right. A lot of math is contrived. Sometimes I make them up. Sometimes my friends make them up. Let's see what we've got here. The cost of sushi restaurant, $600 to provide an all-you-can-eat buffet. Seems like a pretty low estimate there. No, I wouldn't eat there. It sounds like this fish is probably not an excellent quality. If they charge each customer $15, write a linear equation for the profit P in terms of the number of customers X. How many customers do they need to serve to break even? So first, you want to write this equation. Let me see what I've written before, just to see. Okay, oh, that's not even the right one. All right, sure. So we want to set this up. Okay, so our cost is $600, and we're saying we want to know what the profit is. Our profit is going to be P, and X is going to be the number of customers. Right? They've helped us out here a little bit. So if I was doing this and I didn't have a really good idea of what was happening, I might just start writing down a few examples. Like if they have, I might even make a table. So if X were, let's say they had 0 customers. Well, they made $0. Well, actually, they made negative $600, right? Because they have their revenue from people coming and eating the sushi, and then they have their cost, which you have to subtract off. So their profit is going to be $0 of income minus the $600 of cost. Okay. What if they had, let's not just go one by one. Let's say they had 10 customers. If they had 10 customers, how many dollars would they have brought in? 150. minus the 600 of cost. So, okay, getting better. And we could keep doing this, right? We could go up to 20 and say, okay, you're going to get 20 people times $15 minus 600, and that's going to give you negative $300. But I think after a couple steps, you start to see the pattern or the idea for how we're actually going to write the function. Right? Because what we're doing is we're taking the number of people, we're multiplying it by 15, right? That's how many dollars they're bringing in, and subtracting off the cost. So it looks like you could probably write the function for profit, P, or as I would probably encourage you to write it, P of X, right? Because profit is a function of the number of customers. It's going to be 15 times X minus 600. And then there was a second question. The question now is, how many customers till we break even? Well, what does breaking even mean in terms of profit? Zero profit. So literally, we're just setting the profit equal to 0. Right? It's important to think about the meaning of these things, right? You might not have thought about what that meant, and now we have. Okay, great. Yeah, if you want to break even, it's just 0 profit. I feel like the 16 series typically deals more with like these profit cost questions. Like it feels like it's more of a feature of that series. But so there's like, you want to be familiar with the terms like revenue and cost and profit and what they kind of, how they differ from each other. Which we'll definitely talk about in the various co-classes you will all take next quarter, except for the people taking the 21 series. You should take 21A next quarter. Okay. So we said that equal to 0. We get 15x equal to 600. X is 600 divided by 15, which is 40. So we need 40 customers to break even. And I will say, yes, I will say that I will say a lot, but I will say that when you're answering a word question like this, it's often good to include some words in your answer. Right? You could have written your answer as x equals 40, and you probably would have been just fine. But it's often good to be more descriptive about what your answer is, because people are looking for meaning. This also comes up like when you have related rates types questions, which you will all see in your first quarter of calculus, where they're asking you like, how fast is this thing moving when this other thing is moving that way? And the answer isn't just like 12, it's 12 feet per second, or it's 12 meters per hour, or right, there are units attached to it. So it's good to be more descriptive with your answers. All right, we're gonna have time at the end here. So if you have questions about the homework that you want to ask, I know the homework was due already. I know also on Gradescope, it'll let you turn it in a little bit later because I said that so you can turn it a little bit later. It's okay to turn. Yeah, I said it's okay, and I start to choke. It's okay to turn it a little bit later. You should turn it on time if you can, but if I know, especially over the weekend, like you don't have, especially the first week, if there aren't other resources available to you, there's not a lot of opportunity to get help from other people. So if you didn't get it turned in already, you want to ask, or even if you did get it turned in already, you want to ask questions, perfectly fine. All right. A ball, let's see the questions. A ball is thrown upward from an initial height of 4 feet with a velocity of 80 feet per second. The height of the ball as a function of time is given by this lovely equation here. Let's just write it down again. During what time interval will the ball be at least 100 feet above the ground? Okay, so they're asking at what time, or really should say at what times, will the height be greater than or equal to 100 feet? I think that's what the question's asking. During what time interval will the ball be at least 100 feet above the ground? Yeah. So we're being asked to set up and solve an inequality here. We know that, so again, if you want to kind of write some things down, you could start plugging in some numbers. It's not going to be very efficient, but you'd be like, okay, well, I know the height at time 0 is 1. I know the height after 1 second of being thrown upward is going to be negative 16 plus 80 plus 4, which is, I don't know, let's see, 64 plus 4, 68 feet high. And you could go on this way. And the height of the ball after 2 seconds would be negative 16 times 4 plus 80 times 2. Yes. Plus 4, which is, let's see, negative 64 plus, okay, that's exactly 100. I got lucky there. But, and then let me make sure, let me look at something here. Okay. This one is set up in a way where if you kept going, you could totally guess all the right numbers because they're often made to be nice. But the point is, it's still going to be time consuming and inefficient. What we want to do is we want to say, well, I really want to find all the time values where this height, negative 16t squared plus 80t plus 4 is greater than or equal to 100. It's also worth thinking about what the path of a ball thrown actually looks like. Right? It kind of does this parabolic thing where the ball does that. And it's starting at a height of 4 feet. And it's going to end at a height of 0 feet. Right? But you're going to throw it up, it's going to reach some peak, it's going to come back down. That's how most things thrown into the air. So we want to solve this inequality. Well, if I were solving an inequality like this, I would try to make my coefficient of the highest power of my variable positive. I would recommend this always, really. If you're trying to solve an equation, inequality, whatever, I'd really prefer that to be a positive. It just makes things easier. There's 2 ways to achieve this. One is to bring everything to the right. That's totally an option. I know we usually like to leave our equation on the left, but you can bring it all to the right, and that's also fine. So I could say, I'm going to have a 0 over here, bigger than or equal to positive 16t squared minus 80t, and 100 minus 4 is 96. Or you could have brought the 100 to the left and had negative 16t squared plus 80t minus 96 bigger than or equal to 0, and then multiply both sides by negative 1. Then had positive 16t squared minus 80t plus 96 less than or equal to 0 because you would change the direction of the inequality. Let me, instead of just saying the words, let me actually show you. We could have done this instead. And then if you multiply both sides by negative 1, you get 16t squared minus 80t plus 96 is less than or equal to 0 because when you multiply an inequality by a negative, you change the direction of the inequality. And it's the same. I know it's written slightly differently, but this less than or equal to 0 is the same as 0 bigger than or equal to this. So do it whichever way you like, right? They both work. To solve this, let's go ahead and just work from here since I'm kind of room. We are fortunate here in that each of these numbers is a multiple of 16. 80 is 16 times 5, 96 is 16 times 6. So if I divide both sides by 16, I get t squared minus 5t plus 6 is less than or equal to 0. Ooh. And now we can factor that. I think, can we factor that? Yeah. So let me ask you all, am I looking for a 6 and a 1 or a 2 and a 3? A 2 and a 3, a minus 2 and a minus 3 specifically. But I'll just warn you, right? If it's a plus or minus 5 here and a plus or minus 6 here, it always factors. Sometimes it's a 5 and a 6 and a 1, sometimes it's a 2 and a 3. Just be careful because it's easy to miss the signs. So we need a negative 2 and a negative 3 because those multiply to positive 6 and add up to negative 5. And I want to see when that's less than or equal to 0. So I'm going to use the number line. Look at when t is 2, when t is 3. So when t is either equal to 2 or 3, this expression is equal to 0. But when t is, say, bigger than 3, like 4, you get a positive times a positive, which is positive. when t is between 2 and 3, like 2.5, 2.5 minus 2 is positive. So 2.5 minus 3 is negative, and a positive times a negative is negative. And then when t is less than 2, like 1, well, in fact, we already know we don't want that, right? When t is 1, it's not high enough. It's going to be positive over here because it's going to not satisfy the inequality that we want. So if t is equal to 1, we get negative times a negative, which is positive. So the t values that satisfy this inequality are the t values that make this expression negative, which are exactly the values between 2 and 3. That's where that expression is negative. Right, this part here is the t minus 2 times t minus 3. And we want the part where it's negative or equal to 0. So our solution, the time interval that satisfies the question, is t between 2 seconds and 3 seconds. So, right, and we saw that. I mean, we kind of saw it, right? At 2 seconds, it's going to hit 100 feet high. It's going to keep going up. It's going to max out probably at 2.5 seconds. And then it's going to come back down, and at 3 seconds. In fact, if you plugged in 3 here, you would totally see that you also get it equal to 100. Because you get negative 144 plus 240 plus 4 is 100. So, yeah. And those are that is all I have planned for today.